This video is for Homework and Mastery 1.7, Sections 5.2 and 5.3 in your textbook. Multiples and least common multiples of algebraic expressions, along with adding and subtracting fractions. What we want to do here is look at finding multiples. What I mean by multiples is taking the first number and then multiplying it by 1, 2, 3, 4, and so forth. So whenever I ask to list the first 6 multiples of 6x and the first 6 multiples of 8x, I'm literally asking you to say 6x times 1, 6x times 2, 6x times 3, and so forth, until you get to 6x times 6. And the same thing with 8x. So here I have done that very thing. 6x times 1 is 6x. 6x times 2 is 12x. 6x times 3 is 18x, and so forth. These are considered the multiples of 6x. This row is considered the multiples of 8x. Multiples is where I've taken a number and multiplied it by other numbers. The next thing I want to do is, which of these multiples are common in both lists? Well, if you notice, 24 is the only common multiple. And wherever I say common, they have to have the same coefficient, or number, as well as the same variables. In this case, they share the 24 and the x. Therefore, common to both lists is 24x. If I want to find the least common multiple of 15 and 20, this means the common multiple that occurs the first time, or the earliest. There are many common multiples of 15 and 20. I want the lowest common multiple of 15 and 20 though. So the first step I want to do is I want to list out the multiples of 15 and 20. So here they are. The multiples of 15 are 15, 30, 45, 60, and 75. Multiples of 20 are 20, 40, 60, 80, and 100. Do you see anything common between those two lists? Yes, the 60 is common. Therefore, our least common multiple is 60. That is the first number that is common between the two numbers. There are several different ways to build what we call the least common multiple. One way is through prime factorization. We first write a prime factorization that satisfies the first requirement and then add the factorization to satisfy the second requirement. What we want to do is we want to factor each number into a product of prime factors, list the requirements for the factorization of the LCM, or least common multiple, and then build the least common multiple using minimum number of factors. Let's look at what this means. I want to find the least common multiple of 8, 12, and 42. First, I want to factor each number. Then I'll list the requirements for factorization of the LCM, and then I'll build the LCM. Well, here are the first two, 8 and 12, factored out. The 8 requires that the LCM have at least have at least 3 2's. So whenever I build the LCM is going to have 3 2's. The 12 says that I must have at least 2 2's and a 3. Well, according to my 8, I already have at least 2 2's, so I need to add a 3. Now, 42, looking at its prime factors, has a 2, a 3, and a 7. So according to its requirements, it must have a 2, a 3, and a 7. Well, I have a 2, I have a 3, but I need a 7. Therefore, the LCM of 8, 12, and 42 is 2 times 2 times 2 times 3 times 7, or 168. This is one way of building an LCM. Here's another method. I want to find the LCM of 14x, 36, and 7x squared. And so what I've done is I've drawn rows for each number and then a row for the LCM. And I'm going to take each one and factor them. Well, 14x is the same thing as 2 times 7 times x. Notice I've placed each number in its own column. 36 is the same thing as 2 times 2 times 3 times 3. 7x squared is the same thing as 7 times x times x. Now notice, each column only has the same number. I did not line up the 7 here over this 2, and I didn't line an x up over the 3. I can only put in a column the same number. This helps me out with my LCM, because now then my LCM has to have one number from each column. As shown here, it's going to have a 2 from this column, a 2 from this column, a 3 from this column, a 3 from this column, a 7, an x, and an x. And then I multiply this row together, and I get 2 times 2 times 3 times 3 times 7 times x, which gives me 252x squared. Shannon and Marcia are swimming laps from the dock on one side of the lake to a marker and back. Shannon can swim a lap in 12 minutes, and Marcia can swim the same distance in 10 minutes. If Shannon and Martha start swimming at the same time, in how many minutes will they meet to begin the next lap together? Well, what they're wanting us to do is find a least common multiple of 10 and 12. That's when they will start a new lap together. So let's first organize our information in a table. Shannon, her first lap ends at 12 minutes. Her second lap ends at 24 minutes. And so forth. Marcia, first lap ends at 10 minutes. Second lap ends at 20 minutes. This process is what we're doing is gathering the facts. We've seen a mathematical blueprint before, and we're going to use it here. The first step of the mathematical blueprint is to gather the facts. The second step is to see what are you being asked for. Well, I'm asked to find out how many minutes it will take them to begin another lap together. I want to proceed by finding the LCM of 12 and 10. A key point to remember is that the LCM is the least, or the smallest, common multiple. So I solve this by factoring 10 and 12. 12 is 2 times 2 times 3. 10 is 2 times 5. They each have a 2. The 12 has another 2 and a 3, and the 10 has a 5. So their least common multiple is going to be 2 times 2 times 3 times 5, which will be 60. Therefore, Marcia and Shannon will begin another lap together 60 minutes after they start. Sonia and Leo are tour guides at a castle. Sonia gives a 40-minute tour of the interior of the castle, and Leo gives a 10-minute tour of the castle grounds. There is a 10-minute break after each tour. If the tours start at 8 a.m., what is the next time that both tours will start at the same time? We have to remember a couple of things here. First of all, the interior start every 50 minutes because the tours last 40 minutes and then you have a 10-minute break. The grounds tours start every 40 minutes because they last 30 minutes, and you take a 10-minute break. So after 8 o'clock, they each start at 8 o'clock. The next interior tour will be at 8:50. The next grounds tour will be at 8:40, and so forth. We're asked to determine when the next time the tours will begin at the same time. So what we're wanting to do is find the LCM of 40 and 50. One thing to remember is that there's 60 minutes equal to 1 hour. After we find the LCM, we want to change the number of minutes into hours and minutes because it wants to know what time, not just how long after 8 o'clock. It wants to know exactly what time. So such as 9 o'clock, 10 o'clock, things like that. So here's what we do, is we factor out 40 and 50, and we get 2 times 2 times 2 times 5. We factor out 50 and get 2 times 5 times 5. Now they both have a 2, and then the 40 has another set of 2's. The 50 has 2 5's. So this now becomes our least common multiple. 2 times 2 times 2 times 5 times 5, which is 200. So 200 minutes after 8 o'clock, they start together. But it asked us at what time. So I come down here and I take 200 divided by 60, and that gives me 3 hours with 20 minutes left over. So 3 hours and 20 minutes after 8 o'clock, which will be 11:20. This is what time that Sonia and Leo will start their tours again together. The reason that we've been looking at least common multiples is because we're going to need them when we start adding and subtracting fractions. We've already learned how to multiply and divide fractions, but we need to know how to add and subtract fractions. So let's start with looking at adding and subtracting fractions with the common denominator. If they have the same denominator, we just add or subtract the numerators only, and the denominators stay the same. So we don't have to do anything with the least common multiple yet, but we just need to remember that the denominator stays the same. So we start out with 8/11 minus 3/11. The denominators are the same, so I'm going to take 8 minus 3, which is 5, and notice my denominator stayed the same throughout the entire process. Look at negative 27 over 43 plus 15 over 43. The denominators are the same. Therefore, I can look at it as negative 27 plus 15 all over 43. Notice my denominator stayed the same. I add the numerators and I get negative 12 over 43, which will be my final answer. It doesn't matter what my denominator is. My denominator can be a variable, such as it is here. I have 6 over y minus 3 over y. Denominators are still the same, so I can look at it as 6 minus 3 all over y, which leaves me with 3y. Now on the other hand, I have x over 7 plus 5 over 7. Again, my denominators are the same, and so I can look at it as x plus 5 over 7. Here, on my numerators, I don't have common terms. Therefore, I cannot combine anything, and this would actually be my final answer. So if fractions already have a common denominator, I'm just going to add and subtract their numerators, leaving their denominator the same. If they do not have the same denominator, that's when we have to make sure that we find a least common denominator. The least common denominator will be the least common multiple of the two denominators. We then write equivalent fractions, which we have seen before, that have the LCD, or least common denominator, as the new denominator. After we have done so, we add or subtract the numerators with the common denominators. And we must always remember to simplify the answer if necessary. So let's look at -5/7 plus 5/8. They do not have the same denominator. So our first step is to find a common denominator, common multiple, of 7 and 8. In this case, the LCD is going to be 56, which is 7 times 8. Our next step is we need to write equivalent fractions. And what we're trying to do is make 7 into 56 and 8 into 56. How we do that is we say 7 times 8 gives me 56. Whatever I do to the denominator, remember I have to do to the numerator. And so I get -5 times 8, which is -40. Look at it over here. I have 8 times 7, which is 56. Whatever I did to the denominator, which was multiplied by 7, I have to do to the numerator. So 5 times 7 is 35. Now I can add the numerators of the two fractions because they have the same denominator. And so I'm going to get -40 over 56 plus 35 over 56 is going to give me a -5 over 56. I would reduce if possible. In this case, it's not possible, so -5 over 56 is my final answer. Let's look at 11/12 minus 3/20. They do not have a common denominator, so I need to find their least common denominator between 12 and 20. The least common denominator in this case is actually going to be 60. And now I need to write equivalent fractions, making sure that the denominators become 60. So I take 12 times 5, which gives me 60. Whatever I do to the denominator, I must do to the numerator. 11 times 5, which is 55. 3 times 20 gives me 60. I multiplied the denominator by 3, so I have to multiply the numerator by 3, which gives me 9 over 60. Now I can just subtract the two fractions, 55 over 60 minus 9 over 60, which will give me 46 over 60. But notice, this one can be simplified because I can look at both of these and factor out a 2. You always have to remember to look at things and see, can they be factored out any farther? In this case, they can. 23 over 30. Here we have a variable in the denominator, an x. That's perfectly legal. The denominators are not the same though, because I've got an x and I've got a 4x. So my denominator, least common denominator, is actually going to be 4x, because I can multiply this x by a 4 to get 4x and write my equivalent fractions. Remember, whatever I do to the denominator, I do to the numerator, and I get 28 over 4x and 3 over 4x. I'm going to add the numerators, 28 plus 3, which gives me 31 over 4x. Here I have 5 over y minus 3 over x. So what would my common denominator be? It's actually going to be x times y. And so what I'm going to do is I'm going to multiply my first fraction, numerator and denominator, by an x, and multiply my second fraction by a y, which is what I've done here. And I get 5x over xy and 3y over xy. I subtract their numerators and leave my denominator the same. Now, whenever I subtract their numerators, 5x minus 3y, notice they are not common terms. Therefore, I cannot simplify them any farther. Always make sure when you're adding or subtracting fractions that you find that least common denominator. That is going to be the key. Once you do find the least common denominator, you have to remember whatever you did to the denominator, you must also do to the numerator. So if you multiplied the denominator by 5, you must multiply the numerator by 5. If you have any trouble, let one of us know and we'll be glad to help.